The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, depending on where you're logging in from today. That'll sound just about right. Thanks for joining us. We've got a great webinar scheduled for you. We're going to get started here in about 3 minutes or so. It's about 11:57 here local time in Cleveland. And all three of us today are in Ohio. We've got Jim Vajda and Dave Halasz here, and we'll get some introductions done in a second, but I'd love to hear from all of you, and if you could, let us know where you're dialing in from. We'd appreciate it, and I'll give you some shout outs here, just as we always do each week. We've got a lot of great interest on this topic. It's an excellent one, not only here in the US, but it certainly applies globally as well, and all the innovation that's going on around the world. So I've got some folks down in now. Let's see, we've got Vancouver, Oregon, Hillsboro, Oregon. I'm not sure where Hillsboro is. Maybe that's closer to Seattle.
I think that's near Portland.
Oh, it is? Okay.
Yeah,
I really know where Vancouver is. We've got Pennsylvania, California, Texas, more Ohio folks. Welcome. Keep those coming in, folks. We really do appreciate it. I think last week our furthest, if I'm not mistaken, was Thailand. Was that last week, Jim? We had a Thailand attendee, or am I making this up?
No, I'm trying to think. I think we did have Thailand. We also had India, and we had somebody in Moscow.
Oh,
so we did some
right.
math. Somebody was almost like exactly 12 hours ahead or behind. I'm not sure which one it was, but yeah, we get a global audience here, which is awesome.
We do. We've got Iowa. Thanks for buzzing in. I got a shout out for you, Jim. Congratulations on your CBRS cert.
All right. Yeah, I did the Certified Professional Installer certification for CBRS, which was part of the WLPC deep dive I did.
Look at you. You got a little fan club on here.
Yeah, I love that. Thank you, Reza. That's awesome.
And we've got Edinburgh, Scotland. Welcome. And I do see we've got Russia back on. We've got Mexico. We've got some great new distribution partners in Russia and Mexico. Welcome to Comtech and to Sama Wi-Fi. Welcome to the 7 Signal family. So I've got 12 o'clock here on the East Coast time. So why don't we go ahead and get going? So we're trying something new today. We thought we'd bring you a little video presence this week. I hope you guys like it. We're all working from home just like you. If you're not working from home, let us know that too. Go ahead and put that in the chat room. I'm interested to hear how many of us or how many of you, I should say, are still in the office, scrambling away, working on that the day-to-day ops of the enterprise. And I know there's a lot of essential folks on the line and don't get the luxury of working from home. So we certainly feel for you as well. We've got a great topic for you all today, best practices webinar series, as we always have week to week. This week's topic is Wi-Fi 6E. Jim, Dave, and I just sat on the FCC call that started about 10:30 Eastern time. So this is going to be our post-FCC program briefing. I've got Dave Halasz and Jim Vajda on the line, so we're going to meet them in just a few minutes. We've got a couple of housekeeping slides to get through, some quick updates, and then we'll get to the show. We're not going to do any product discussions today. We may reference one. So if you're looking for 7 Signal products and overviews, you're going to have to go and wait till Friday when we have our product tour. If you want to register for that, it's go.7signal.com/tour. Very easy to do that. We will share a copy of today's recording and the slides, so no need to ask for those as we go on. And we'll also post it to YouTube, where we do share all of our archived webinars. So if you're looking for some general topics or really specific stuff, we've got a great library of over 30 webinars that we've presented in the past 18 months or so. So please use that as your reference. moving forward. We do have some special offers going on right now because of COVID and the situation that we're all in. We are helping organizations just like yours troubleshoot their remote workforce for Wi-Fi connectivity issues. So this offer that we have is for our prospect base. So if you're not a customer of 7Signal, we are offering 50 Mobileye licenses for 50 days. You can go to go.7signal.com/50 for 50, and I'll drop these into the chat if you don't have your pen and paper handy. And this is our customer promotion. If you're a customer and don't have Mobileye, if you're just a Sapphire customer, you can go to go.7signal.com/1000 for 60. So we are giving 1,000 licenses of Mobileye away to our customers for 60 days to help them through this pandemic. A little bit about 7Signal, and then we're going to get going here. 7Signal was founded in 2007 in Helsinki, Finland. We moved to the US in 2010, and we've been really busy in that time. So we're crunching a lot of numbers over here. We're tracking over 1 billion data points on a day-to-day basis, monitoring over 1 million wireless devices. We're on a lot of networks, Cisco customers, Aruba customers, Mist customers. It spreads the gamut. Over 200 customers around the world, over 30 partners. I mentioned just a handful before we got going. But our product is certified in over 40 countries around the world. We're GDPR compliant, so not only do we care about the technology stack staying current, we also care about privacy and respect that. So GDPR compliance was something we added last year, very, very important for the organization. Over 13 patents in the US. So what you see from 7Signal from a product standpoint, you're only going to see from us. In a nutshell, 7Signal is here to enable the wireless world. And what we're doing is we're finding and fixing Wi-Fi issues. So since 2007, when the company started, we created an outside-in enterprise framework. We're the only organization that has that. Completely AP and device agnostic, completely modular, so depending on your challenges that are unique to your organization, depending on if you're in healthcare or retail or manufacturing or any other industry, we'll have the right solution for you. And it may not be both solutions, it may be one, it may just be services. All of our products are replete with reporting and analytics. And what we're doing is we're looking for the top 7 Wi-Fi problems. Everything in the world of Wi-Fi bubbles up to one of these problems. They certainly don't present themselves this way. You know, all the issues present themselves as you either can't connect or the connectivity is slow, but there's a reason for it. And we help our customers get to the root cause of those issues. Things like congestion, coverage, interference, network services, roaming issues, etc. And how we're doing it is we're running active and passive tests on your network and on your devices for things like packet loss, latency and jitter, MOS scores, throughput, having a full spectrum analysis so you're able to get to those interference causes in a moment's notice and be proactive with your Wi-Fi. So I mentioned that 7Signal created that outside-in enterprise framework. So it's important to know the difference between the legacy approach that our prospective customers have and what our customers enjoy, which is the outside-in approach. So if you're not a 7Signal customer, you're relying on your access points or the devices to tell you what's going on with connectivity. And there's good information there, right? We're here to complement your access points and your devices. We're certainly not competing. And the information that we're providing to our customers gives them great visibility into the end user experience. So device teams love us. Help desk teams love us. The network engineers love us. Really because we live on the edge. We live in the outside. So our products install on devices, or we have hardware that installs in the rafters with the access points. So we're monitoring. We're a third party that monitors all the activity that's going on in the world of Wi-Fi. And we enable our customers to get to the root cause quickly, so they can go back in time and take a snapshot of what was going on in the network at that given time, and able to see those devices on the network. And we do that 2 ways. We've got 2 products. One is Mobileye there on the left. The other is Sapphire. Mobileye is our 100% SaaS-based client that lives on the device itself as an application, looking for things like adapter issues, driver issues, roaming issues, co-channel and adjacent issues, coverage, congestion, that kind of stuff. And Sapphire Eye is our perfect client. It's software-enabled hardware that lives up in the access points with up in the rafters with the access points, or down on a desktop or on a wall, wherever it's installed. That's got the full spectrum analysis, but it does more network services type things, your wireless LAN configuration, that sort of stuff. So real differentiation in the products. We're the only vendor in the industry to offer this complete product set. So thank you for letting me share that. Now we're going to get on with the show. We've got two speakers, as you guys see, with me today. First is Dave Halasz, longtime 7 Signal engineer. Dave, tell us a little bit about yourself.
Sure. Yeah, thanks, Don. I'm a solutions engineer here, CWNA approved, and I've got a lot of experience with wireless, over 25 years in product development and solutions engineering. That I did work at Cisco Systems. That's for people familiar with the AeroNet product line. 7 Signal is in Northern Ohio, and also the AeroNet was an acquisition that was in the Northern Ohio area. And I was recognized as a Cisco innovator there. Also, I kind of led a lot of the early security development. I chaired 802.11i. For people that are familiar with that, that was the basis of WPA and WPA2. And then I chaired more recently 802.11ah. I was the initial sub 1 gigahertz chair. And then I was also kind of going way back that I was involved with the formation of the Wi-Fi Alliance. And then I've got a number of patents, all involving wireless.
All right, thank you, Dave. With your background chairing those orgs, it should be interesting to hear your feedback today around how the FCC did in launching Wi-Fi 6E.
Yeah.
All right, and also with us today, Mr. Jim Vajda. Jim, tell us a little bit about yourself.
Yeah, good to be here. Thanks. Let me switch over to sharing my screen. Great. And Dave, I just had a question. Was WECA the wireless Ethernet alliance that predated the Wi-Fi alliance?
Not you ask. I don't know. I remember it was called
WECA. A long time ago.
Yeah.
Yeah, and then they officially changed it to Wi-Fi because everybody knew Wi-Fi, but if you said WECA, nobody knew what you're talking about.
Cool. Anyway, Jim Vajda here, Director of Global Wi-Fi Solutions at 7 Signal. I deal mostly with pre-sales engineering. I'm a CWNE and Cisco CCNP wireless. I've got wireless network experience across a lot of different verticals, and you can follow me on Twitter at Jim Vajda, where I've been tweeting about 6 gigahertz for a while. And also I have a blog, framebyframewifi.net, that's entirely about Wi-Fi if you just want to follow me there.
Thanks, Jim.
Cool. So yeah, so let's kind of get into it. I think, one of the first things we want to clear up is sort of what's Wi-Fi 6E, what's Wi-Fi 6, what's 802.11ax, because we have a lot of new terms kind of floating around now, and adding the 6 gigahertz band adds another layer of confusion, perhaps.
Yeah, that the part that the Wi-Fi generations, something that's relatively new. Jim, would you say like maybe they changed this maybe a year ago or something?
Yeah, I think it was 2018 where they came out with this. It came out with 802.11ax getting introduced. It still hasn't been fully ratified, but the Wi-Fi Alliance decided, and I think they had a good point, that talking about Wi-Fi in terms of the technical specification it comes from for end users and consumers is really confusing, right? 802.11ax, 802.11ac, 802.11n, those don't tell you really, if you're not, a wireless engineer, what's better and which one you should buy. So wouldn't it be better if we just said Wi-Fi, 4, Wi-Fi 5, Wi-Fi 6, then the higher numbers are better, kind of like 3G, 4G, 5G, simple enough.
I think the real reason was they make these labels, and it says like, before it used to say B, A, G, N, A, C.
Oh, that's true. Yeah, I remember those. Yeah.
They ran out of room on those labels. What are we going to do? I know, we'll call it Wi-Fi 5.
Exactly. But the takeaway is that Wi-Fi 6 is the is what is certified by the Wi-Fi Alliance for 802.11ax. The IEEE makes the 802.11ax standard. The Wi-Fi Alliance calls it Wi-Fi 6 for marketing and branding. And similarly, they kind of went backwards and said, okay, Wi-Fi 5 is 802.11ac and Wi-Fi 4 is 802.11n. I've never seen those terms actually used, but I have seen Wi-Fi 6 used, out in the wild quite a bit. So that yeah, go ahead.
I was just going to agree with you. I think that it's the transition is with Wi-Fi 6 that you start to hear that more instead of the AX and so forth.
Yeah, so let's talk about Wi-Fi 6E. So Wi-Fi 6 is the 802.11ax amendment, and it supports operation in the 2.4 gigahertz band and the 5 gigahertz band. But Wi-Fi 6E is the exact same thing. We just add support for the 6 gigahertz band as well. And the 6 gigahertz band is what the FCC voted on just about an hour ago to allow for unlicensed operation here in the United States.
Yeah, that's something else that I was, same comment that I wanted to stress is that when it's the FCC, that's the US.
Yeah.
And so, yes, that the same type of technology is going to want to be used, of course, around the world. But today's announcement was strictly a U.S. type of thing since it was the FCC.
Yeah, and the U.S. went first. Other regulatory domains are looking very closely at doing things similar to what the FCC did, but the FCC has gone first this time. So what does this look like? Well, I just wanted to highlight one of the sentences from the NPRM that was voted on, or now it's the report in order. But this is kind of the declaration that they've opened the entire 6 gigahertz band for indoor unlicensed operations without the need for AFC or automatic frequency controlled access. So to give you an idea of how much more spectrum this is that Wi-Fi will be able to use, we've got this chart here, and at the top, you've got the 2.4 gigahertz band with just those 3 non-overlapping 20 megahertz wide channels. That's the ISM band. Right below that, we're looking at the 5 gigahertz band. That's the band where high density and high capacity applications really require the spectrum that it provides. And then below that, that third row is the new 6 gigahertz unlicensed band that the FCC created today. So an enormous increase in available spectrum.
Yeah, so I'm sure that a lot of our users are familiar with the operation of 2.4 versus 5 gigahertz, and we'll get into this a little bit more throughout the slides. But you're probably used to say, hey, especially as a lot of our customers that are like universities run into this, that's students would think, at home, I got an access point and it works fine. Why can't it work as nicely in this other environment, like in the university or a campus or something like that? And the reason why is because you've got more than one access point. When you do that, the amount of space that is available to you is directly impacted. It's not as easy to set up a campus versus just one access point. And that's where the size of that 2.4 channel versus the 5 gigahertz, that's directly impacting this. That's why that 5 gigahertz operates a lot better. So now you can start to look and say 6 gigahertz, wow, that's a lot there.
Yeah, so we'll start to get into some of the implications of what that spectrum allows. This is a deeper look at the 5 gigahertz band. And one of the challenges in 5 gigahertz is in that Uni 2 extended band and Uni 2. Every single one of those channels in the United States requires DFS operation. So you have to listen for radars and other incumbents in the band and vacate the channel if it's occupied. With Wi-Fi 6 in the 6 gigahertz band, if you're at low power and operating indoors, you're that LPI class of device, you don't have any DFS restrictions like that. So that's pretty cool.
Yeah, likewise, when we look, if you look at this graph, one of the things that's going to jump out at you is that, well, what if you wanted to run, for instance, 11AC has got the 120 megahertz wide channel. Well, what if you've got radar that is around you, and then you've got no channels? There's nowhere that, you know, you cannot have a 120 megahertz wide channel. And that's kind of like part of the issue there, is that, and likewise, even if you did have like one channel, now if you try to put this in an office, well, you know, what are you going to do? That there's, you know, just one channel, you're going to be overlapping with each other. So really kind of comes into a problem. Then you have the additional things about DFS, and we'll be talking about DFS and AFC a little bit more.
Yeah, that's right. Yeah, when you're designing a network, even in your typical office, you know, 80 megahertz wide channels, 160 megahertz wide channels, they don't work. There's not enough available spectrum. Even with DFS channels, you still have a significant amount of channel overlap and co-channel interference that, you know, a lot of people just, when working with 5 gigahertz, they'll default to 20 megahertz channel width. And then if there's, you know, maybe there's enough spectral reuse, yeah, we'll try 40, but 80 and 160, even though it was built into 802.11ac, rarely ever used in the enterprise. So let's talk a little bit more about what DFS and AFC are, just to kind of compare and contrast the existing rules we have in 5 gigahertz to the new rules we have in 6 gigahertz. So dynamic frequency selection is for that part of the band where it's required, means that the AP there is constantly monitoring the channel, looking for the RF signature of certain incumbents. So that could be military, certainly weather radar is a well-known incumbent, and if it detects it, then it has to leave. And you know, that's been a false positives is a big problem with DFS operation. And so what the FCC has tried to do with AFC is overcome some of those obstacles. So again, those low power indoor APs won't be required to have any AFC operation at all, but standard power APs, which can operate at higher power and operate outdoors, use this AFC function to avoid those incumbents that are there in the 6 gigahertz band. So, you know, DFS is important. It solved a real problem, and you know, it keeps unlicensed use away from critical systems like the terminal Doppler weather radars that airports use to detect wind shear. You know, if an airliner is landing and there's significant wind shear, that could be a catastrophe. And so it's important we're not interfering with those operations so they maintain that radar visibility. But DFS caused a lot of problems for us as it solved problems for incumbents. The, you know, overriding concern is the uncertainty of it. Maybe, you know, in my experience, an AP may have operated on a DFS channel for 6 months without any radar detects, and boom, all of a sudden it gets one. And then there's the question of how legitimate was that DFS hit? Was it a false positive, or was it a real event? Another issue there is slower AP discovery, because a client cannot just go onto the channel and transmit a probe request looking for an AP. It has to sit there and passively listen because it can only transmit under the control of an AP. So that increases the amount of dwell time on each channel that the client takes while it's scanning. That's really bad for voice over IP performance. If you have to wait for a beacon that might take 100 milliseconds to come, then you're dropping, audio packets at the same time. And so a lot of voice over Wi-Fi designs recommend against using DFS channels altogether for that reason.
Hey, Jim?
So, yeah, go ahead.
I got a question that came in from the audience that's relevant to that last comment, so I just wanted to bring it up. It said, regarding AFC for external APs on standard power, do you anticipate installers having to be licensed to ensure compliance?
That's a good question, because that is the case with, in some cases, with Category B CBSDs and CBRS. That's not the case here with 6 gigahertz. That was an open question that was discussed pretty extensively in the NPRM, but no, professional installation is not required, but there are additional requirements on those AFC or standard power APs that we'll get into. And we'll talk about that a little bit later, so we'll get into that.
Yeah, with the dynamic frequency selection, there are a lot of challenges that kind of go along with it too. To say some of these radars, sometimes they're not just from a device. What would it see? It's not like it might not actually see it constantly. It might see it in that some of these radars they might be that the antenna might be moving. So you might get it, so you detect it, and all of a sudden, period of time, it's like, hey, it went away.
Yeah,
Now it came back again.
Yeah, the antenna could be on a military aircraft that flew by one day and tripped all your APs.
Right, and so what you end up having is that, if you think about it with your wireless LAN, you'd say, I'd rather have it so that I just didn't go to those channels. That would be a better decision than to go to it, all of a sudden have to move off of it, not be able to kind of come back for like another minute. It just creates this tremendous disruption. Well, it kind of like made it so that a lot of people found that they really couldn't use it. So
and
so therefore
it's just totally unavailable. Yeah.
And so then when you look at AFC, which we'll talk about a little bit more as well, that it's kind of like, well, what were the problems with DFS and can we get past that? And so that's where they're trying to address.
Yeah, and so even if you kind of do the best practice where you stand up an AP at the new, Wi-Fi site and put it on every single DFS channel and let it stay there for a while and see if you get any hits, that doesn't really tell you what's going to happen in the future.
Right. And Nick's got a comment here. It said someone told him that Wi-Fi clients can be a source of DFS false positive. Have you guys heard the same thing?
Yeah, that's absolutely true. One of the ways you can kind of keep an eye on that is if you have a Wi-Fi network, that typically gets loaded during the day and then gets unloaded at night. Well, if you are seeing DFS hits kind of track as, that same pattern of being loaded with clients and then unloaded at night, no DFS hits at night and then the weekend, there's a good chance that clients may be the source of some of those false positives. So it's, it's a challenge to get that to work. And, again, you can see in this chart, Uni 2A, Uni 2C, the new terms for those bands are require DFS. It's just Uni 1 and Uni 3 in 5 gigahertz where we can get away with not using DFS. So let's again look at the 6 gigahertz band and talk a little bit more in depth about the different classes of devices that were authorized today. So low power indoors, I'll call it LPI for short, can use all 59 channels across the whole band, no AFC. There's some special rules about it. They really want it to be indoor use only. So that's a little bit different than other APs. And then these standard power APs are AFC controlled, and they can use most of the band, Uni 5 and Uni 7, but incumbents in other areas, especially I think it was Uni 8, are so frequent that the FCC wouldn't allow that that type of operation.
Yeah, the key thing here is you look at it and you say, from a Wi-Fi perspective, you're like, well, why is this? It's the thing to keep in mind is that, well, there's other stuff there. There's when you read the NPRM, if you bother reading it, then you'll see the word incumbent, and what that's referring to is there's other technologies that are actually operating there, and what they're doing is saying, okay, you know what, we can have both of these devices, the incumbents, and then add in Wi-Fi into this space if we adopt these types of rules. So the FCC kind of comes up with the rules based off of the feedback from industry, and so that's why you kind of look and say, oh, when the FCC looked at it, when they talk about like the different uni bands, what they're talking about is they kind of put it into categories. It's like, okay, type of incumbents that are in this area, they kind of fall into a certain category, and then there's this category, and that's why that it kind of is in certain different sections.
Yeah, that's right. And we can look a little bit closer. By the way, shout out to WLAN Pros and Keith Parsons for letting us use these graphs in our webinar today. That was very generous of him. But one of the things you'll see here, and as we look a little bit closer about these two classes, LPI and standard power, in a 20 megahertz channel, those LPI devices can transmit, the APs can transmit at 18 dBm. Standard power AP can transmit at 36 dBm. So big difference in power. And one of the things I wanted to mention too, the reason AFC, one of the major incumbents that AFC is protecting is point-to-point wireless links, and these are licensed. These are commercial operations that were licensed by the FCC, and so they're paying a premium to have access to spectrum. And now the FCC is coming along and saying, hey, Wi-Fi is going to be using the same spectrum, so that's why AFC is required. It will protect those local incumbents, so that Wi-Fi and anything else that's playing in the band is not going to interfere with them.
And that includes 5G. I just got a question from Robert about that very thing.
That's right. 5G also has to play by these same rules too. So our focus is on Wi-Fi, of course, but any wireless protocol that's operating in an unlicensed fashion under these rules will be subject to the same rules from the FCC.
Yeah, the FCC tries to be technology independent. Obviously, that there's we have the Wi-Fi hats on, and now that they're used to a number of the industry players, they're from the Wi-Fi industry kind of coming forward. So that's where, but other technologies, as long as they play by the rules that the FCC lays down, then they're able to operate there as well.
Sorry, Dave. So a question from Manish said, who's the primary user of the 6 gigahertz band? Is it WLAN or is it 5G?
We'll see.
So, yeah.
Certainly, there's a lot of movement for both 5G and Wi-Fi to use that spectrum, and I'll have some comments about that here in a couple slides.
Yeah, I think that's more of a prediction type of thing. So I agree with Jim that it's more of a, well, I guess we'll end up seeing. Obviously, the Wi-Fi industry as a whole has done a lot of work to kind of like lay this kind of forward. So, that obviously that industry is going to be looking to say, yeah, we're definitely going to be using this. One of the things that kind of like hit me was we were looking at this is like, well, have we seen this before? And I think that, when Jim was showing some of the slides of 2.4 versus 5 gigahertz versus 6 gigahertz, well, what is this kind of like similar to? Well, way back when we did have 11G and 11A, and with 11A that there was a lot of advantages to going to 5 gigahertz. it was kind of like, oh, the area's clean up here. You know, you got more channels. That there's something called protection mechanisms. I'm not sure if the users have kind of noticed, but you might have seen it. Like if you're on 2.4, even if you had no interference and you just had like one access point, then you'd say, okay, let me try to do a run 802.11g and compare it to 11a. You would see that 11a actually runs quicker and that the channel utilization is lower. And so you kind of say, well, but isn't it kind of like the same thing? Well, there is some other things that, that's because 11g is in 2.4, Wi-Fi does a great job of having backward compatibility, but there's a cost to it. And that cost is you have to do things like, oh, how do I make it so that these things play nice together? And so that's what the way that things are made to play nicely together are things that we call protection mechanisms. So that's the new technology. For instance, in 11G with OFDM, it does some activity to make sure that it allows the older technology to operate and work. And then the other thing is that you've got these with up to 4, that older technology, that there's these very low data rates, and that also has something that's some implications as far as that the transmissions are much larger, take much longer, end up taking it, and so therefore, even if you've got like this brand new 11G at the time, that you would end up operating slower because of that. And then the other thing that we kind of like discussed before is that there is some difference here. If you use that analogy, that if you use the analogy of 11G and 11A, then they actually had the same highest raw data rate of 54 megabits per second. But with Wi-Fi 6E, it was kind of shown, you really can't, 11AC had 160 megahertz wide channels, but in a carpeted office, you really can't use that in 5 gigahertz, that it's just not practical. So now that analogy is really kind of shown that if you're looking at it going from 11G to 11A, it's actually much better because now you can use some of those higher data rates that you wanted to use. So.
Yeah, some of those features that have been around for a while we'll finally get to take advantage of outside of labs. And let's talk a little bit about, AFC and sort of its history.
Sure.
You know a little bit about the TV white space initiative and the systems that sort of predated what we're doing now in 6 gigahertz, right?
Yeah, that the phrase that I kind of like is that people are familiar with Disney movies. It's like, oh yeah, it's all coming together. There's a lot of work that was kind of going on, and that even when that's 802.11, they do kind of like think of things as to what are the things that we could work on, and then we could apply to other technologies in the future. So they make sense then, and then they also make sense in the future. So when we talk about AFC, then you might say, well, okay, you guys said AFC, but what exactly is it? What ends up happening is the access point is going to contact some database. And it's going to, so when the access point contacts us, it say, hey, I'm at this location. So since I'm in this location, geographic location, for instance, I'm in Kent, Ohio. If I'm in Kent, Ohio, where can what are the frequencies that I can operate? Can I operate on these frequencies? And then the database comes back and tells it, you could, operate blah, blah on these channels and so forth, because we know that for instance, there aren't any of these incumbents in your area. So therefore it's not a problem that you could end up running with higher power.
That's such a big advantage over what we do with DFS, because now all that uncertainty is gone. You query the AFC database and it tells you, okay, operate on these channels. Now it could change in the future, right? So doesn't mean new licensees could be coming into the band operation. The channels that are available could change, but it does give you some way of knowing at least where to expect incumbents to be and knowing what channels you're authorized to be on.
Yeah, and you wouldn't expect these things to change dramatically.
No. Right.
That's I think the rules have it like that the access point has to check like once a day.
Yeah.
Well, the other thing that was kind of going along, if we looked at 11AC, oh, I should say then also kind of follow up with the TV white spaces. So what IEEE community ended up doing was then kind of like working with, come up with, okay, here's a database, the same mechanism. It's not exactly the same because of the rules are a little bit different and the incumbents are different, but that the access point will contact the database, and the database response will kind of indicate whether you could operate on those channels. That was already done with TV white spaces 8 to 11AF. So now when the IEEE and the Wi-Fi Alliance community kind of comes to the FCC, it's not like they're waving their hands and saying, oh, sure, we could do this. They have something that they could show and say, look, we're going to use, we already showed you that this will work in the real world. So therefore, that's why that we believe that it's going to work for the 6 gigahertz. And then the other thing that kind of goes along with it, and it's like, well, why do you need so much more bandwidth? And then if it's not really practical to transmit 160 megahertz wide channels, then why do I need to do this? But that with 11AC, even though we were kind of making the comments that in a carpeted office, it's not really practical. At a home, where you just got like one access point or two, sure, you could do that. And so therefore, Wi-Fi Alliance, they come along with and say, hey, look, we could get these 160 megahertz wide channels working, and showed that. So now it's when you go to the FCC, it's not like you could just, hey, can you do this for me? And they're going to say yes. There's a tremendous amount of work that has to go on, that you kind of have to show that this is a viable thing that you're going to work on. Those two things together, then working with the FCC to come up with that 6 gigahertz band, you're going to see this tremendously, vastly improved performance going forward.
Yeah, definitely. So let's get through these next few slides so we have a few more minutes for questions. This is right from the NPRM about the transmit power that's allowed. They're using a different mechanism than Wi-Fi engineers are used to for coming up with these transmit powers. What it kind of looks like with the channel widths that we're used to is starting at 18 dBm. Again, this is for low power indoors. 18 dBm at 20 megahertz channel width. Then you go up 3 dB for every doubling of the channel width, all the way up to 320 megahertz, which is going to be part of Wi-Fi 7, as much as I hoped it wouldn't be. That's the maximum allowed channel width the FCC has allowed. And so that kind of stepping up accounts for the increase in noise as you increase the width of the channel. So but that's kind of a nice feature, especially since we expect wide channels to be in use here. Now, one note is the FCC is not quite done making rules. There's a further NPRM that proposes to increase these limits by 3 dB, which would be nice, certainly. Some of the commissioners this morning expressed support for that, which was good to hear. And the other interesting part here is kind of like the cellular world. The AP can transmit at a higher power than the client device. So the client max power is always 6 dB below the AP it's connected to.
Yeah, that is kind of interesting. I know, so Jim and I were kind of talking beforehand, is that as we kind of look at this, a lot of the things that we do look at is that having the connection balance between clients and access points. So it's kind of like changing somewhat, but also with 802.11ax brings in OFDMA, which you might have heard about, and there is some like implications for that as far as the way that these radios can connect up. So it also kind of comes together. It's almost sort of like changing the way that the fundamental protocols of 802.11 and Wi-Fi are kind of working in.
Yeah, it's interesting. A couple more things about LPI. All this is designed to make sure that these devices are really only used indoors. They can't be weather sealed. The antennas must be integrated. That's the term they use. They did not say internal. So I think that sort of leaves the door open for having, directional antennas sort of built into an AP and still giving you some flexibility. I don't think it means only typical omnidirectional internal antennas. No external antenna leads. Again, they don't want you using high gain antennas with the possibility of putting the antenna outdoor and the AP inside. Can't be operated on battery power. That's interesting. So this isn't for mobile things. It has to be labeled for indoor use only. So those were interesting. Then we mentioned the further NPRM. It also introduces a third class. So we have standard power APs, we have LPI, low power indoors APs, and the further NPRM will decide on if this third class very low power APs will be allowed. These devices will have access to the whole band under the proposal. AFC won't be required. They can go indoors or outdoors, but the TX power will be quite a bit below LPI. So we're thinking, where LPI wasn't allowed to be battery powered and really was, not meant to be mobile, VLP will allow for, hotspots and travel routers and those kind of battery operated things that people expect from Wi-Fi. But that's all to be determined. Another point, 6 gigahertz, we had a question about this, is unlicensed spectrum. It's technology neutral. If you can play by the rules that the FCC set out, then your protocol can work in that. Already, before today's decision, ultra wideband was already approved under Part 15 rules to operate in an unlicensed fashion in the band. It's crazy low power though, so not a problem. And 5G, the 5G NRU standard from 3GPP is built to support the 6 gigahertz band. And now that doesn't mean that the cellular carriers are going to come in and chew up all the spectrum in your enterprise. It could mean that you are thinking about deploying 5G for certain applications, and now you've got 1200 megahertz of spectrum that you can, carefully divide up between Wi-Fi and Wi-Fi 6E and 5G and 5G NRU. So it gives you additional flexibility to use the spectrum however you see fit. And there'll be more. I mean, this is the biggest chunk of unlicensed spectrum that we have access to. So certainly in the future, more protocols will support it. But what I think is really good news is the FCC requires that a contention-based protocol, and they don't get very much more specific than that, is required to operate here. So that usually means something like a listen before talk protocol. They did mention CSMA, CA that Wi-Fi has as an example, but that's good. We won't have, you have to at least, have some degree of politeness before accessing the band. We'll see how that plays out when protocols are finalized. So a couple things about what we'll see for Wi-Fi 6 in the enterprise. Certainly try radio APs with the 2, 4, 5 gigahertz and 6 gigahertz radio will be coming. These will have multi-gigabit Ethernet backhaul, and they'll probably require 60 watt PoE. So for a lot of shops, that's a wholesale switching upgrade that's very expensive. I wonder, Dave, and I'd like your take on this, will we see dual radio APs where we'd say, I don't want to deal with replacing my whole switching infrastructure just to continue supporting 2.4 gigahertz. Can I have just a dual radio AP with a smaller PoE budget and have just 5 and 6 gigahertz radios?
Yeah, I think that as we're looking at some of our customers, that they end up, going away from 2.4. For instance, that's, I've got my headset on and then I'm coming to you over Wi-Fi. And so when you really want to, a lot of customers end up seeing this just because of the things that we've mentioned as far as the amount of room that you've got, that running like voice becomes very challenging in 2.4 because you've got these other interference sources that you really can't control. And so therefore it's not really reliable to you. So then we do find customers just saying, well, you know what, we're only going to go with 5 gigahertz. So I could definitely see that. The other thing I could see is like these tri-band with a halo radio on.
Ah, I love that.
Of course, I don't know if I've ever
Probably
actually
fit that
seen
into 30 watts. Well, it's interesting too, because with 802.11ac, support for 2.4 gigahertz was dropped, and 2.4 gigahertz was dead the first time. And then it came back. 802.11ax is going to support 2.4 gigahertz. But now with Wi-Fi 6E and this potential for dual radio APs that don't have it, maybe it's dead again.
Yeah, one of the things about
We'll see.
AX is the OFDMA, and I do kind of question the backward compatibility or using that, the really getting out what you really wanted out of OFDMA when you're in the presence of older technologies.
Yeah,
I could
that's
see
why having this native spectrum is so key. So, a couple other ideas here, where we'll see it first. I'm sure that large public venue operators are really hungry for additional spectrum for Wi-Fi and for 5G. High density areas, even I think there's residential use cases, particularly for mesh backhaul, right? You keep your access radios on 2, 4, and 5, backhaul on 6 gigahertz. Fixed wireless access, WISPs will certainly take interest. And again, 1480 megahertz wide channels means we can start using wide channels again. But much to my chagrin, Wi-Fi 7 is going to bring on the possibility of 320 megahertz channel widths, and that leaves only 3 non-overlapping channels in the band. So we'll see how that's addressed.
Yeah, one of the other things kind of along those same lines is that I think you mentioned like the mesh APs, which are kind of becoming very popular in homes for extended coverage, and that you might have seen then also in our slides that we're talking about different transmit powers between an access point and a client. And so that the FCC did clarify this as far as they talk about a subordinate access point. And what they mean by that is one of these mesh APs, because technically that mesh AP is a client. So does that mesh AP now have to run at low power? The answer is no. It's the same as when they're in the low power mode, that they could operate with the same transmit power as an access point.
Nice. So we don't have DFS or AFC rules for low power indoors, but we do have some restrictions on discovery. We can't just go and probe on channels until we've heard an AP transmission. That's actually similar to the way DFS works. You can only passively scan those channels to discover those APs. So the good news though is in the legacy bands 2, 4, and 5, there'll be this 6 gigahertz operation information element. So you probe on 5 gigahertz, you find an AP, and its probe response tells you, here I am on channel 36 in 5 gigahertz, and I have a radio on channel 200 or whatever it is in 6 gigahertz. And then once you're operating in 6 gigahertz, maybe 802.11k neighbor reports will help you discover those other APs as well. So there are some band-aids for that. Just other tidbits, it's not mobile, and there were some question about will this be allowed to be used in airplanes. Appears to be the case, and early question in the webinar, professional installation is not required, but geolocation for that AFC system is required, and that can be done through onboard built-in GPS, and you can even run a antenna lead out to the outside of the building as part of the installation to make that GPS work.
Yeah, there are some other things with AFC that when we talk about it, kind of like being a win-win, that's when it comes to DFS, if there was a device that was not quite abiding by the rules, the FCC would kind of come in and have to hunt them down, and if they'd have to address it, it's kind of more of like a spot thing. But because of this mechanism, seeing it's not essentially controlled, if there is an issue, that the database could kind of look and say, hey, it's this type of device and this device is having a problem, so I will restrict it.
Yep. Yeah, very handy. So Don, we went a little long. We have a few minutes for Q&A.
Yeah, we do. We've got a lot of questions. So if you guys can help me, I'm going to ask these questions in order. But as we come a little closer up on 1 o'clock here local time, it gives us about 8 minutes for questions. Rest assured, if we don't answer your question on here, we will email you the answer to it if indeed we have it. So, and some of these are pretty specific. So let me just start and see where this takes us. So the first question here from Rick, do you think that dynamic spectrum sharing in CBRS will be better than the dynamic frequency selection in 5 gigahertz?
Yes, I do, because the CBRS system, the SAS operates much like the AFC system we described for 6 gigahertz. So I think the AFC in 6 gigahertz and SAS in CBRS are both improvements on DFS.
From Olivier, who runs the AFCs? Do you foresee the same companies that run CBRS, SAS, and Federated Wireless? Any AFCs available today? That was a tongue twister.
Dave, you want to take that one?
Yeah, they're open to companies. Yeah, and you'd end up seeing, when I was looking at the TV white space, it was companies such as Microsoft, Google, that had these systems. Yeah, I foresee them kind of continuing on with that.
All right. Let's see. This one is from Rick. Question about Wi-Fi 6E for home users. Since wave 5G signals don't pass through walls, will Wi-Fi 6E be an option for in-home Wi-Fi access points?
Absolutely.
Yeah.
Hey, go ahead, Dave.
I was going to just say that definitely that you could see that that the low power would be. We might end up seeing like these low power access points being. So you might have more of them. So like that mesh type of operation might make sense. And then also then if you do have that the standard power option where it kind of goes back and then kind of figures out if it can run at higher power. I definitely would see that happening in the house. Now you do have a point that this is, when they talked about it, they kind of said about indoor, they were very specific. It was not an accident per se, and that they were kind of looking at the incumbents and saying, okay, that if you're going to go through, they do the modeling of saying, okay, because you're indoor, to go through the roof and so forth, that how much attenuation you have, and that, obviously you're going to get that through your walls as well. So you will have a smaller cell, you've got a lot lower transmit power, but I definitely see that in the house.
So this as a comment from John. So a 6E client will not be able to turn up as a hotspot and walk out of the office. I don't know if you...
Currently.
Yeah, not under those low power indoors rules. That's what VLP, the very low power rules, may address, is that hotspot or ad hoc network. Exactly.
Let's see. Comment, I believe that 2.4 is back in Wi-Fi 6 with BSS coloring, from Richard.
Yeah, BSS coloring is a part of AX, so it applies to wherever it's being used. So it's also on 2.4. And it's a way of making it so that you could dynamically change your thresholds for when you would back off or whether you're transmit or not. And it helps to know, oh, this is this access point, or no, I'm not actually on that access point, it's coming from something else. So I could adjust my threshold based off of that.
Yeah, and you could also see OFDMA helping with operation in the noisy 2.4 gigahertz band, because you can use those slices of the channel, not the full 20 megahertz, to transmit and receive onto certain clients to avoid noise that's out there.
Mm-hmm. So I'll end it with this question. It's more of a comment, and there's a couple other ones around this as well. So if the FCC does get rid of the 2.4 gigahertz, it's going to be a significant problem with cheaper IoT devices, and not only cheap devices. I've got someone in here with a hospital concern as well. So what do you guys think? You know, is the end in sight maybe for 2.4 devices, or?
No. When I said that 2.4 gigahertz was dead again, what I was really talking about is from a Wi-Fi perspective. You know, we've tried to get away from using it because the spectrum is so limited and it's noisy and there's other protocols there. I don't see any indication that the FCC intends to change that band and turn it off for unlicensed spectrum because it's so highly utilized by so many protocols. But for the best Wi-Fi performance, it's the last band you want to use. And I'm sensitive to that. I came from healthcare and had to support a lot of legacy 2.4 only devices, and those things aren't going anywhere anytime soon.
Yeah, I agree with that. That's the other thing to keep in mind with 2.4 is that it's worldwide. So therefore, it's not just the FCC. And then the FCC wouldn't say, well, we're getting rid of it because the Wi-Fi Alliance says so, because, well, there's all this other stuff that's there, unlicensed device. And then as Jim mentioned, then there are nice things about 2.4, kind of like when I mentioned Halo. Halo was the 802.11ah, which was going to 900 megahertz. And the reason for that is you're not interested in performance, really, you're interested in Internet of Things. So going to that lower band does allow you to go further. And so then you might see that, oh, maybe what Wi-Fi Alliance does is they end up having these indoor Internet of Things that are running in 2.4, which are running with AX, they get better battery savings because they're running on smaller sub channels and so forth.
We have one more minute. And I see an interesting question from Roger, and maybe we could go off air with this one, or this will take us to close in the last 60 seconds. Roger from South Africa. My question here there are claims that 5G will simply and clearly replace Wi-Fi. Is this true? Maybe
No.
that's a good closing.
These are complementary technologies. 5G and cellular are your outdoor technology. Wi-Fi is your indoor technology. 5G has benefits, but it's also more expensive. Wi-Fi is unlicensed, anyone can deploy it. So, there are use cases that are great for each one, and they'll continue to complement each other.
Yeah, the thing that I would add is that my cell phone, where I'm sitting right now, does not work over cellular. And so when I went into my carrier, they told me, well, don't you have that voice over Wi-Fi feature? I just turn that on. I'm like, okay. So my carrier told me to run voice over Wi-Fi. Yeah. So do I think that it's gonna, Wi-Fi is gonna go away because of the carrier technologies? No, I don't think so.
All right, gentlemen, well done. Thanks for presenting to all of us today. We really do appreciate it. Love having you guys here. Everyone on the line, thanks for joining us. We ran a little bit over, and the majority of you stayed with us, which we do appreciate as well. So thank you, everyone. Stay safe and healthy. Enjoy the rest of the week, and we'll see you all next week. Bye.
Thanks, guys.
Yeah, thanks. Bye.